Hi friends, my name is Madan Kumar, EC Department, Tyagaraja College of Engineering. Let me discuss on problems on single stage and multi-stage amplifier. I hope you are familiar with the concepts and theory on theoretical part on single stage and multi-stage amplifier. So let me straight away move on to the problems now. These are some formulas for solving the problems on single stage and multi-stage amplifier. These are the important formulas because these formulas not only help you to solve these single stage and multi-stage amplifier, also it helps you to solve the problems on negative feedback amplifiers, which will be covered in the later part of the syllabus. Okay, so please remember those formulas. So as I already told you, all strong with the conceptual part on this single stage and multi-stage amplifier concepts. So you all know about the derivation and the final result of this derivation only shown in this slide, in this particular slide. So no need to worry about derivation. Just concentrate on these formulas because these formulas are very important. These formulas talks about various points like first one is current gain, and second one is overall current gain, and input impedance, and overall voltage gain, and voltage gain, and output admittance, and power gain, and so many things. I written them twice. I am written them each one twice, so don't confuse with that. So please remember this formula. I stressing these words again and again because these formulas are helping you to solve so many problems after not only in this single stage and multi-stage, also in this amplified type of sums. So please remember these formulas. Now let me move on to the first problem, single stage amplifier. Before starting this problem session, I am going to tell you one thing. Actually, transistors classified of two types, NPN and PNP, and biasing applied to the transistor also classified to three types: voltage divider bias, the series feedback bias, and collector based feedback bias. These three things. And also transistor also classified into three types, namely common emitter, common collector, common base. So there are so many types of configurations which can be made by using these three combinations in NPN, PNP, and common emitter, common collector, and type of biasing. But here in this problem session, I'm going to discuss only two problems. One problem is on single stage amplifier, and another one problem on multi-stage, that is nothing but double stage amplifier. So I'm going to discuss about these two problems. These two problems are based on common emitter, NPN, and voltage divider bias configured transistor. I'm saying once again, NPN, common emitter, and voltage divider bias configured problems. So please understand these problems very clearly what I am going to tell, because if you understand these problems very clearly, then it will be useful for to solve any kind of problem which are asked in any exams. Okay, so please understand those very carefully. So I'm once again saying I'm only going to discuss two problems of particular configuration. Remaining configuration you can try it by your own. Now in this first question we see that single stage amplifier. All these two questions I have taken from the book which is written by the author Uday A, Bakshi and Godse. So this is example 4.3 which I have taken from that. The first one is given as a single stage common emitter amplifier with RS is equal to 1 kilo ohms, and R1 is equal to 50 kilo ohms, and R2 is equal to 2 kilo ohms, RC 2 kilo ohms, etc. And HI is equal to 1.1 kilo ohms, and etc. Some others are given. So all these specifications are given. Now our aim is also, the circuit diagram are also given. Now our aim is to find the current gain, input impedance nothing but RI, and voltage gain AV, and AI is equal to IL by IS. Actually that is the overall current gain, which what is my overall current gain, which I will tell later. And second one is the overall voltage gain V1 by Vs, and finally output resistance. So these six we need to calculate for this sum. Now let me move on to the problem. Okay, now let me see the problem. In the given problem, before solving this problem, they converted the given circuit in the H parameter equivalent. I hope you are familiar with how to convert any given transistor circuit into its H parameter equivalent. The first step is to make all the active sources to be grounded, and make all the capacitors to be shorted, and convert them to the H parameter equivalent model. Okay, before that, divide the transistor into the three components. I think two components, that is nothing but one resistor in the input side and one current source in the output side. So these 4 things you need to remember before converting the any given transistor circuit diagram into the simplified hybrid model. And remember one thing, we are dividing the any given transistor circuit into the hybrid model for our convenience. Okay, for our convenience only we are dividing into this given transistor circuit diagram into hybrid model. It is not necessary. If you are very comfortable and if you are very experienced and if you are very equipped with by solving without the help of hybrid model means, then you can proceed accordingly. Okay, there is no need to come into the hybrid model. Actually, the hybrid model will take some amount of time, but if you draw it correctly, then the solving of problems will be very clear and it will not get confused. If you are familiar with more number of questions and more number of diagrams, then automatically afterwards solving, for example, if you are solving the 5 problems by drawing the H parameter diagram again and again, during solving the sixth problem, no need to draw this H parameter circuit diagram, because now at the time you will get familiar about this transistor circuit diagram, amplifier circuit diagram. Okay, so H parameters only for make our problem solving technique easier. It's just a problem solving technique, remember those things. So please don't think this as a complex thing. Now the first question, as they asked in the previous slide, we need to calculate the current gain. Current gain is something but the HFE. Actually H parameters classified into 4 things: HI, HR, HO and HF. Okay, HO is output admittance, HR is reverse voltage gain, HI is forward current gain, and HF is current gain. Okay, so these are the 4 things we need to remember. So the first one is here as they given, we need to calculate the current gain AA is equal to minus HFE. Okay, as per the formula which we saw in the previous slide, current gain AA is equal to minus HFE, which is equal to minus 50. Okay, don't worry, all the details which I used here are given in the question. Okay, no need to worry about that. Next, input impedance. Next, the input impedance must be equal to, I'm told wrongly. Actually HI is the input impedance, H0 is the output admittance, and HF is the forward current gain, and HR is the reverse voltage gain. Okay, sorry for the wrong side. So correct it. So now let me calculate the input impedance. Ri is equal to HI is equal to 1.1k, and we need to calculate the Ri dash. That Ri dash is equal to, please, if you focus on the input side, you see that there is not only HI, there is also R1 and R2 which is connected in parallel to the HI. So while calculating the Ri dash, we need to include those 2 resistors also. So Ri dash is equal to R1 parallel with R2 parallel with HI, which is equal to 700 ohms. And finally voltage gain is equal to AA into RL by Ri. Okay, this formula, I hope you remember this formula from the previous slide. Ohms value is minus 45 by 45. All these are mere substitution only, so don't need to worry about that. All these are very substitution only. You use the formula correctly and make use of calculator, you will get the answer correctly. Okay, and output impedance is R0 is equal to 1 by Y0, because as in the previous slide they taken that HOE is equal to 25 mu amps and HR is equal to 2.5 into 10 power minus 4. Okay, did you notice it? Actually this HOE and HRE are very negligible value. Okay, so if we add this in the calculate, if we add this also in the calculation, there is no great change in the value. Okay, so I can consider this HOE and HR is a negligible quantity, so I can make 0 of this quantity. Okay, so in most of the books, in most of the problems they consider HOE and the HR as a negligible quantity only. So no need to worry about this. So only here output impedance R0 is equal to 1 by I0, which is equal to infinity. So I hope you are clear in this slide. Now let's move on to the next slide. And similarly here they calculate the R0 dash is equal to R0 parallel to RL dash, because here R0 is the output impedance and RL dash is the output load resistors in parallel with the other output resistance components. So R0, the overall R0 dash is equal to R0 parallel to RL dash, which is equal to 1k. And next to overall voltage gain. Note my point, voltage gain or current gain is nothing but simply output voltage by output input voltage or output current by input current respectively. If we are using the term overall voltage gain AVS or overall current AAS, means we are going to calculate the voltage gain or current gain along with the source resistance. Okay, so only we are using the symbol AVS. S stands for voltage gain, sorry, AVS means it stands for voltage gain along with the source resistance. Similarly, AIS means current gain along with the source resistance. So here V0 by Vs. For a calculation, we use the multiply by divide by VB, and where V0 by VB is equal to AV, because voltage gain is equal to output voltage by input voltage. So V0 by VB is equal to AV, and VB by Vs is equal to Ri dash by Ri dash plus Rs. Since if you seen in the previous circuit diagram, by applying the voltage divider rule, we get this VB is equal to Vs into Ri dash by Ri dash plus Rs. From that we calculate the VB by Vs, and substituting values, we get minus 18.71. Please make the substitution correctly so to get the correct answer. Okay, now similarly we can calculate the overall current gain. Overall current gain nothing but the output current by input current. Normal current gain is nothing but the output current by input current. By the overall current gain is nothing but the current gain by including the source resistance also. So that we are using AA is equal to IL by IS. And here also, by making some computations, here also, so to make our calculation easier, we are multiplying the dividing by IC and IB. Okay, now IL by IC is equal to minus RC by RC plus RL, which is known as the current divider rule in figure 4.25. You can observe this current divider rule from figure 4.29 and 4.30, which is equal to minus 0.5, and IC by IB is equal to HFE, because HFE, as I previously told, HFE is the current gain. So current gain is equal to output current by input current. IC by IB is equal to 50. I forgot to tell one thing. Since here we are using the NPN transistor, so and also common emitter. So for common emitter NPN transistor, the input current will be the IB and output current will be the IC. Okay, so that's all in this slide. So IC by IB is HFE, and next we make the substitution and find out the value accordingly. So, and finally we substitute the value for IB by IS is equal to RB by RB plus RI, and we find the overall current gain AIS. Here they wrongly given as AI, actually it's a AIS is equal to IL by IS is equal to minus 0.5 into 50 into 0.636 is equal to minus 15/9. Make the substitution correctly to get the correct answer. So that's all. This is the end of this problem of single stage amplifier. Now from the next slide we will move on to the multi-stage amplifier. Here I explained only the single stage amplifier for only one type of configuration, NPN common emitter configuration. Similarly, you can try for common base NPN or common base PNP or common collector PNP or common collector NPN, anything you can try, but make the substitution and formulas correctly and make anything changes if needed. Okay, so that's all. Now from the next slide we will move on to the multi-stage amplifier problem. Thank you. So from this slide onwards we are going to see about the problem multi-stage amplifier. This is also simple thing only. The only difference between the multi-stage amplifier and the single stage amplifier is nothing but in this multi-stage amplifier we need to calculate whatever we find out in the single stage amplifier for two transistors. So that is the only difference between the multi-stage and single stage. Okay, not only two transistors, because there is also 3-stage amplifier, 4-stage amplifier, 5-stage amplifier, but now for our convenience we are using the only up to 2-stage amplifier. Okay, so this is also very easy to calculate. Here also I am going to discuss only about the only one type of configuration. So if you understand this clearly, you can able to find out any number of calculations any number of configurations very easily. Here the given question, they ask us to find the ZI input impedance and output impedance and the overall voltage gain and overall current gain for the given circuit. And let me assume the given transistor to be identical with HI is equal to 1.1 kilo ohms and HFE is equal to 50, which is nothing but HFE is nothing but current gain, and HRE and HOE are negligible. So as I already told in the single stage amplifier, in most of the problems and most of the time they will given that HRE and HOE are negligible. So here also they follow the same method as they given HOE and HRE are negligible. Okay, now this is a given transistor circuit diagram. Now let me this consists of two transistors. Q1 is the common emitter transistor and Q2 is the common collector transistor. Our aim is to calculate the overall output voltage, that is nothing but V0. Okay, Our aim is not to calculate the output of the Q1. Our aim is to calculate the output voltage of the Q2. So that's our aim. So that's all. Now let me move on to the problem. Here in this diagram they shown the AC equivalent circuit of the given circuit diagram. In the single stage amplifier they directly put down the H parameter circuit. By finding out the AC equivalent circuit, we will only able to construct the H parameter circuit only after finding the AC equivalent circuit. But here they didn't put out the H parameter circuit. Instead of that, they directly put down the AC equivalent circuit and they skip into the problem. So here we see that there is no need of H parameter circuit. If you need it, you can draw. There is no any problem. But as I already told, if I get familiar with problems, no need to draw them because they are simply time wasting. But that will makes you to understand the concept very easily. Now they show the in the figure 4.43, this is the AC equivalent circuit of the given amplifier diagram. Now let me calculate, as I already told, let me find out all the parameters one by one for each of the transistor. Let me do the analysis for the second stage. That is second stage is the common collector amplifier. Since here HR and HO negligible, we can use the approximate analysis. I hope you know about the transistor approximate analysis and exact analysis. I hope you understood. So let me skip on to that. No need to involve in that. Here they calculate the current gain is equal to A2 is equal to 1 plus HFE. Okay. Even you can also directly use HFE also because there is no any big variation. If you use HFE means it is equal to 50. If you are using 1 plus HFE means it is equal to 51. There is no any big difference in this value, 50, 51. So no need anything. But the exact calculation is 1 plus HFE. So the current gain for the second stage amplifier is A2 is equal to 1 plus HFE, which is equal to 1 plus 50 is equal to 51. Similarly, we can calculate the input resistance, which is equal to for the first stage, which is equal to Ri2, which is equal to HIE plus 1 plus HFE into RL2. The value is 511.1K. And similarly, voltage gain is equal to the formula which we see in the previous slide. So when I am stressing again and again, please remember those formulas. AB2 is equal to A2 into RL2 by Ri2, whose value is 0.97. Similarly, let me calculate the analysis of the first stage of the common emitter amplifier. Okay. Now we seen about the second stage, which is common collector configuration. Now we are going to see about the analysis of first stage, which is common emitter amplifier. This analysis is similar to the what we seen in the single stage amplifier. Okay, since HRE and HO are negligible, we use approximate analysis. Since this analysis of first stage is similar to the what I see in the single stage amplifier, all those formulas applied at the place are also applicable here also. So current gain is equal to minus HFE is equal to minus 50, and input resistance is equal to HRE, which is equal to 1.1 kilo ohms, and voltage gain is equal to, by using the formula substitution, we get minus 225, and the overall input resistance, which is nothing but Ri, which is equal to Zi, which is Ri1, which is equal to 1.1 kilo ohms. So that's all in this slide. Now let me calculate the voltage gain of this double stage amplifier, which is equal to the voltage gain of the first stage amplifier into voltage gain of the second stage amplifier. Since this double stage amplifier is a combination of two single stage amplifier, here we calculated the voltage gain separately for two transistors, and finally we multiplied by both together to get the overall voltage of this double stage amplifier. Because our aim is to calculate the output voltage at the end of this second dual stage amplifier. Okay. That means we are giving the input at the base terminal of the first transistor, and the output of the first transistor is fed back again as the input to the base terminal of the second transistor, and finally we got the output from the output terminal of the second transistor. So in that only we measuring the voltage gain, which is equal to minus 224.325. If this voltage gain is said to be dB, then we will need to add it. Okay, that is a simple mathematics. Since dB is said to be in log, we need to add them together. Similarly, we are going to calculate overall voltage gain. Overall voltage gain is nothing but calculating the voltage gain by taking the source resistance into an account. So A base is equal to V1 by Vs. Similarly, for calculation we take as V1 by Vs into V1 by V1, and by applying the voltage divider rule, we get V1 is equal to Vs into Ri by Ri plus Rs, Vi by Vs, and by substitution we get Vi by Vs is equal to 0.6875, and at last we get AVS is equal to AV into VI by VS, which is equal to minus 154.22. And also the overall output resistance, since they given that taken that HR in HO is negligible, we find out that RO2 is approximately equal to ZO2, which is equal to infinity, and RO is equal to Z0, which is equal to R02 parallel to RI2, which is equal to 10K. Okay, these are just mere substitution, so please you use the appropriate formula correct places to find out the correct result. So that's all, we come to the end of our problems. As I already told, I discussed only 2 problems only, and the other problems you can discuss by your own. Okay, because as to my time restriction, I am discuss only 2 problems only. So that's all the end of these problems. Let me close up this video. Thank you.